All right, let's move on to Earth's atmosphere, 4.4. And just before, I want you to really take a look at this. This is how thick it is. This equates to about 60 miles. Probably even less. That's probably 60 is out to here. This is not much, people. This is not very much space. Remember, 60 miles is like here to like Fontana, or here to like Oceanside. Here to I think I already said Fontana, or here to Riverside would be about 60 miles, which is not very far. And I really want to emphasize that this is not very much space for us to mess up. All right, humans have been thinking the oceans or the rivers are too big to mess up. Well, we messed those up. The ocean's too big to mess up. Well, we know we've messed that up. The atmosphere is like our last dumping ground, almost. The last dumping ground where people can think they can just put whatever they want up into the atmosphere. But we know, scientists have known since the 70s that our actions have been having major problems, have been creating major problems over time. And that kind of gets us into, the state of balance. I'm sure you've all heard about the ozone layer, right? That was something scientists have known since the 70s. That's been a problem. And of course, global warming, climate change. And that's something, the first time a scientist warned about that was actually the 1930s. Said, hey, this is burning all this oil, coal, there's going to be some consequences. You just can't get away with putting that much carbon into the atmosphere. And everything's going to be totally fine forever. And then in the 50s, really, in 60s, scientists had the evidence say, yes, we are really changing the climate. And we're seeing the effects of that now. So, ozone layer, balance with upper atmospheric ozone, global warming, issues with CO2 balance. These are all things that our Earth systems have become accustomed to keeping under and below certain thresholds. So once we get away from those thresholds, we can start having serious problems. I just increased the thickness of my right. I don't think it was really showing up as well as I thought it was when I was looking at some of your videos. So thresholds, all about balance. Yeah, that's better. That looks better. We're just throwing things off balance. And just remember, the Earth will recover. But the question is, will we be here? We can mess the Earth up, but it's going to have the last laugh when humans have struggles as we are now, growing enough food, living in areas that are getting hotter and hotter, and desert areas like Southern California, where we're having real issues with getting water. So just the balance of the Earth we need to keep into serious focus. And our overall learning objective for this video, what is the Earth's atmosphere about? And basically the structure, has layers and mostly based on temperature. We'll see as we go up through the atmosphere, we see these different thermal layers occur. And it's kind of interesting. The pattern is pretty interesting. It's pretty easy to remember too. So you're going to like that. Let's get right into it. Let's look at first the composition of the atmosphere. Most of what you are breathing is nitrogen, about 78.1%. Okay, so mostly nitrogen. That's what you are breathing. Carbon is 20.9%. So most people just think of the air being oxygen, but that's not the main component. The main component is nitrogen, and that's changed over time. Earth's early atmosphere was hardly any oxygen and mostly carbon dioxide. And now it's really the reverse. CO2 is 0.04, so it's not very much, but remember, we're adapted for a certain amount. The temperature patterns that life has relied on for the last 3 billion years, 2.5 billion years, have relied on that large percentage of oxygen and low percentage of carbon dioxide. And if we start seeing that change, we can see, effects to life systems here on Earth. And this AR, you might not know what that is, but that's argon, almost 1%, a little bit less. So just think, mainly nitrogen and oxygen. That's basically what you're breathing. And then just like 1.2% other stuff. So mostly we're breathing nitrogen and oxygen. Bringing basically what we're trying to get is that oxygen so we can, undergo cellular respiration. That's why we need to breathe. So this is kind of a nice little graphical representation. And it's kind of laying it out with these blocks. So you saw the pie chart. This gives you a little more representation. Like the big old block, that's the majority. That's our nitrogen. Again, about 78.1%. The second biggest one you'll see is oxygen. Oops, oxygen. You can read that. And I'll write over here. You can actually see on here 20.9, almost 21%. Not quite there. And then these smaller boxes, you might remember, this is argon at 0.9%. Carbon dioxide down here, 0.04. When I was learning this originally, it was 0.03. Really, I think when I was growing up, it was around 380 parts per million. Now we have about 420 parts per million. Let me check that number. It might be 421. Yes, the average, July's numbers aren't in yet because it's an average, but I think it did peak up to 421, but the June average was 420.99. So pretty much 421, and it just keeps going up. And that's really something we need to be concerned with. Luckily, hopefully when you guys are my age, you'll be driving electric cars. There's other sorts of things that are going on. But hopefully it'll be happening soon. I'll be driving electric cars and we will be able to get more renewable. We need to get electricity in through renewable methods. That's the main thing. So go ahead, pause the video and draw your own pie chart and label it. Just give yourself some practice. Moving on, let's look at those layers. This first layer that we live in and the weather lives in is the troposphere. And that's from zero right here. We're breathing. The troposphere goes up about 12 kilometers. Okay, that's about 7 miles. Yeah, 7.2 miles, something like that. This is where you have the weather, clouds, everything we think of as the atmosphere happens here. So in reality, the atmosphere as we know it is really like 7 miles, which is like from Jordan, not even to the ocean. Think about that. All the weather, all that stuff happens between Jordan High School and the ocean. Hold on. I got it. I just thought of something. So here we are, a picture of Ah, man, I can't. Here, just a second. So here we go. Now I got it. I think I can run this. So this is where we are at Jordan. So this area, just all the way across Long Beach, that's about 8 miles. 7, 8 miles. This is where the weather happens. This is where the heart and soul of our atmosphere takes place. That's not very much space, everybody. So I just think about that. That's what we're looking at when we think about, can we just burn stuff and let it go in the air? You know, drive whatever kind of fossil fuel vehicle, burn our trash like we do in Long Beach in a semi environmentally safe way. Everything we put up in the air, that's what we're looking at. That's hardly anything. So troposphere, dang, worse than I thought just before I started doing this. The other layer that you're probably familiar with is a stratosphere. Yeah, this is way better, this thickness. Oh wow, I can't believe I hadn't really fixed that before. So the stratosphere, like, I just think about that. There's that hotel in Las Vegas with the ride at the very top of it, they call it the stratosphere. That goes up from 12 to about 50 kilometers. And that's to the point where you've seen shooting stars coming through. That's where it starts to get thick enough where they can burn up. So, 50 kilometers. It's really starting to get thin at that point. The next layer is the mesosphere. And that goes up to about 80 kilometers. And yeah, this is where these meteors, there's enough friction, enough air molecules there where you can have that friction between the object and the air. Then we get to the thermosphere as we keep going up. And it goes from 80 to 700 kilometers. And you might have heard this aura here. You may have heard it also as the Northern Lights. I think I talked about it earlier. Beautiful glow. Basically, radiation from the sun is dissipating in this in the thermosphere and creating this light display. Just amazing. And then finally the exosphere. And you can see space station. So it's not really the atmosphere, but it's considered the exosphere up to 10,000 kilometers. Now, where does space begin? Officially, it's about 100 kilometers. This is not drawn to scale, so I'll just say 80 kilometers. It's called the Kármán line. We'll look at in a second. Kármán, K-A-R-M-A-N. And that starts about 100 kilometers. Nice round number, right? They chose 100 kilometers. They could have chosen 110, 90, because it's really not distinct. But they just went for the 100. And that equates to about 62 miles for what we're used to. Again, mesosphere, here's where we have meteors burning up. And here we have the auroras. Aurora Borealis, Northern Lights. Oh, that's a beautiful little documentation of it. Now, a lot of you may have heard of the various rocket ships that have been going on. This is Blue Origin. Some of you probably heard of Jeff Bezos from Amazon. This is their rocket that went up, I believe, a couple months ago. This is a capsule sitting on top of a rocket, and as we can see, it shoots up, and then you have the capsule separate right here, and you can tell they're all aiming for that Kármán line. They want to get above that because that officially is space where you get a little bit of microgravity or weightlessness. So that capsule just keeps on trucking along, spends a little bit of time up in space before gravity takes over again. And the main thing is they're reusable. The booster lands so they can reuse it, so they don't have to. Let's see, I can't write behind here. So this is a booster lands. And also the capsule lands. I can't see it behind I have it my setting off. The capsule parachutes to Earth. And then they can say, hey, I went to space. And they can reuse both the capsule and the rocket, which saves a lot of money. The other one that's interesting is this Virgin. This is, you may have heard of Virgin Airlines, Virgin Records. And this is Richard Branson. I almost forgot his name. But kind of this very famous, very out there British billionaire guy. Got rich in the airline industry. Actually, I think he got rich can't remember how he got rich. It wasn't the airline. It's hard to get rich with airline. Richard Branson. But he has his own project. You know, the billionaires, they want to get into space. This is a separate little rocket ship that's attached to a very strange looking plane. And it's called the White Knight. But what happens is it gets up to about 50,000 feet. That's higher, you know. Most commercial airlines fly 35,000 feet, between 35 and 40,000 feet. Well, they get up a little higher than that, and then they separate, and then boom, the rocket goes off on that spaceship too. Again, tries to get up over that Kármán line. Just for a little bit. And there's a little bit of 0 G's, so 0 gravity. And then falls back. And again, it glides back to Earth. So an unpowered glide. And then they can reuse it. To me, this looks more like a spaceship. You know what I mean? Not just a capsule. One person did get killed like a year. This did finally work, I believe. They got this to work. But a pilot was killed. I think there were 2 pilots in this thing, and the fuel blew up too early, and it killed one of the 2 pilots. Now, this is what I mentioned before. Temperature changes with height. Temperature changes. I can do better than that, maybe. Hopefully there's enough contrast for you to see that, but temperature changes with height. Look, we start out on the ground and we see it gets colder initially. Then you get above the troposphere and it gets warmer. Then you get to the stratosphere and it gets colder again. Then you get in the thermosphere and it gets warmer. So, and then you're basically, remember, this is about where we're looking at space. So it's just going to get warmer at that point, the further out in space you go. So it's interesting. I'm not sure exactly how this works, but that's how these layers, the atmosphere is very complicated, you know, weather patterns. And part of the reason why we've been able to get more accurate with forecasting is because we've gotten better computers to try and predict what's going to happen. Like weather balloons, for example, they really only go up to, think about right here. People for a long time. Been putting up weather balloons to see what's going on in the upper atmosphere, and they only get up about 50 kilometers, I believe. Thought I had that. Yeah, so I double checked. Yeah, it's 52 kilometers. So right here is where these weather balloons max out. So that's really, you know, like I mentioned before, we talk about the mesosphere and the thermosphere, but really our atmosphere is mostly the stratosphere, the troposphere. So we need to take care of this atmosphere. And you can do your part. Whatever little bit every person does helps. So I want you to draw and label your own diagram. You can use this as a guide to finish out this topic 4.4.